Hey there, everyone. Thanks for checking in today. Today we're going to talk about how to determine limits using algebraic properties of limits. So you can see here on the first slide, we just have a lot of properties of limits. So let b and c be real numbers and n be a positive integer. Let f and g be functions such that the limit as x approaches c of f is L, and the limit as x approaches c of g is k. So you can kind of read through those 5 limits there: the scalar multiple, the sum and difference, the product, the quotient, and the power rules for these limits. And then we can take a look at a couple examples of how to use them. All right, so given that the limit as x approaches 2 of f is 7, the limit as x approaches 2 of g is 4, and the limit as x approaches 2 of h is -2, we're going to find a couple new limits. So the first one says find the limit as x approaches 2 of 3 times f. So that's using our scalar multiple property. That's just going to be 3 times 7, which is 21. And then for b, the limit as x approaches 2 of f plus g, that's just going to be 7 plus 4, which is 11. And then c, the limit as x approaches 2 of h over g. So that would be -2 over 4. And we can reduce that down, of course, to -1/2. And the last one, the limit as x approaches 2 of f cubed. So that would be 7 cubed, which is 343. All right, so how about from a graph? Consider the graphs of the functions f and g given below. Find each of the following limits. So the first one says find a limit as x approaches 1 of f plus g. So the limit as x approaches 1 of f is 2. The limit as x approaches 1 of g is 1. So 2 plus 1 is 3. For b, the limit as x approaches 3 of g over f. So the limit as x approaches 3 of g would be 0. The limit as x approaches 3 of f, doesn't really matter what it would be, as long as it's a number, which it is, and it's -2, and 0 over anything would give us 0. All right. So the tricky part about this is composition. The basic rule for composition you can see here, if you're trying to find the limit as x approaches a of f of g of x, you're going to find a limit as x approaches a of g, and then do f of that number. But that's only true if f is continuous. Okay, and continuous is not a word we really have learned too much about yet, but basically it means that there's no holes, no breaks, no asymptotes at that x value that we're trying to find. But what if it's not? Okay, that's where things can get a little bit tricky. Okay, then we have to look for are we coming from above or below the limit, and then can we take a left-sided or a right-sided limit from there? So we'll take a look at that and a couple problems here on the next couple slides. So the first one says, find the limit as x approaches 1 of f of g of x. All right, so we want to find the limit as x approaches 1 of g. Looks like both sides are converging to the same point. That would be 0. So then basically, we're going to look at 0 on the f graph, and is it continuous or not? It is continuous, so that means all we got to do then is do f of 0. And f of 0 would be 2. Okay, and again, we got that because the limit as x approaches 1 of g of x was 0, and because f was continuous at 0. All right, the second one, the limit as x approaches 2 of f times g. So the limit as x approaches 2 of f times g. Well, the limit as x approaches 2 of f doesn't really exist here. So what we're going to do is have to do left limit and right limits and see how that looks. So let's do the limit as x approaches 2 from the left of f times g, the left limit of f at 2 would be 0, and the left limit, the left limit of g at 2, looks like that would be probably 1. So that limit would be 0. Now let's see if the right limit agrees with that. So the limit as x approaches 2 from the right of f times g, the right limit of f would be 1. The right limit of g would again be 1, which is 1. So our left-hand limit of this product and the right-hand limit of this product disagree with each other. And therefore, the answer is does not exist. In question C, we have limit as x approaches 0 of f of x. All right, so the first thing we're going to do is take the limit as x approaches 0 of f, and that would be 2. So we're going to find f of 2. The problem with that is f is not continuous at 2. So we can't just find f of 2 and be done with it. Instead, we got to look at which side is this number coming from. We are approaching this. It's approaching 2 from below that y value. Since it's approaching 2 from below that y value, what we're going to do now is we're going to take a limit as x approaches 2 from the left because it's below. If it was coming from above that number, we would look at the right of f of x. So as we approach 2 from the left, our limit would be 0, and therefore our answer to this limit would be 0. All right, so the next one here, the limit as x approaches -1 of f plus g. So limit as x approaches -1 of f plus g. The problem is, for -1 on both these graphs, really, they're not continuous. So we got to do a left-hand, right-hand approach again. So we'll do limit as x approaches -1 from the left of f plus g. The left limit for f would be 1. The left limit for g would be -2. Sorry, -1 and -2. So it's -1 plus -2, which is -3. Now let's take a look at the right-hand limit. Limit as x approaches -1 from the right of f plus g. The right limit for f would be -2. The right limit for g would be -1. So it's -2 plus -1, which is, of course, -3. The left and right limits agree, so we're at -3 for our answer. For this one, again, we're taking the limit as x approaches 1 of f of x, which is fine. That's continuous there. Or it's not continuous, I'm sorry, but the limit exists there. But it's not continuous at g of x plus 1, because that would be g of 2, which is not continuous there. So again, we're going to have to do a left side, right side approach for this one. So limit as x approaches 1 from the left of f would be 2 of g of 1 plus 1. So g of 2 would be 2. So we get 2 plus 2, which is 4. Okay, now we need to see the right-hand limit and see if that's also 4. So for f, again, we're approaching 2 from the right-hand side. But for g, we're approaching 3. So that's 2 plus 3, which is 5. These limits do not agree, and therefore this does not exist. Okay, example 5. Another graph of f and g there. The first one says f of g of 4. This is not a limit, so it just takes g of 4 and then find f of that number. So g of 4 would be 6. So we're just doing f of 6. F of 6 would be 4. So f of g of 4 is 4. But now we're saying, let's do the limit as x approaches 4 of f of g of x. Okay? So the first thing we're going to do is the limit as x approaches 4 of g of x, and see what that is. And that would again be 6, because both sides are going towards 6. The problem is that f is not continuous at 6, as we can see here. So we got to look, all right, so this graph was coming from under 6. So therefore, we're going to do a left-hand limit. So limit as x approaches 4 from the, x approaches 6 from the left of f of x. Because this is coming from under 6. So as x approaches 6 from the left, we get our answer to be 1. So our limit here is 1. Part C, f of g of 0. So g of 0 looks to be -2. So we're going to find f of -2, which is 1. So f of g of 0 is 1. Now for D, the limit as x approaches 0 of f of g of x. So the limit as x approaches 0 of g of x would be -2, right? But at -2, f is not continuous. So that limit is coming from above -2. So what we're going to do is we're going to take a right-hand limit. A limit as x approaches -2 from the right of f of x. And that would be 3. So our limit here is 3. Part E. We're going to start here by doing the limit as x approaches 6 from the left of 1 minus f of x. So that would be 1 minus, as x approaches 6 from the left, 1, which is 0. Since g of x is continuous at 0, our limit would just be g of 0, which is -2. So our answer is -2. Part F, we're going to start here by doing the limit as x approaches 3 from the right of 15 minus x squared. All right, if you don't know what 15 minus x squared is, all it is a parabola that looks like this. Okay? And 3 would be right around here. If you put 3 into that expression, 15 minus 3 squared, 15 minus 9, that would be 6. And if we're coming from the right, we're coming from below 6. Okay, why is that important? Because f is not continuous at 6. So since it's coming from below 6 on this graph, we're going to do the limit as x approaches 6 from the left of f of x for our final answer. And that would be 1. So our limit here is 1. Part G, so we're going to start here by doing the limit as x approaches 2 from the left of 2 minus x squared. So again, that's just going to be an upside down parabola. If you put 2 in there, you can get 2 minus 4, which is -2. So from the left, we're approaching that from above, which is important, again, because we have to see if g is continuous at -2, which it is not. So we have to approach that from the right side because this approaches it from the above. So we're going to do a limit as x approaches -2 from the right side of g of x. And that would be 0, which means our answer to this limit is 0. Okay, and the last one, limit as x approaches -2 from the left of f. So we're going to start by doing of just f. And that limit would be -2, which is coming at it from above. So keep that in mind here. So limit is -2 from above. Since f is not continuous at -2, we have to use the fact that it's coming at it from above in our original limit. That means we're only going to take the right-hand limit for our final answer here. So limit as x approaches -2 from the right of f. Which is 3. All right, so that's it for our algebraic properties of limits. I know the composition part was a little confusing. If you ever need help, obviously you can just let me know. Have a good night, and I'll see you next time.